Well, welcome everyone to a presentation on LKFT Remote Labs. My name is Ryan Arnold. I'm the Director of Core Technology and Tools at Linaro. We're the team that does Lava, the Linaro Lab, QA, systems, toolchain, and builds and baselines. So we are the team that put together the Linux Kernel Functional Test project in support of Project Sharp. And I'm going to go through a presentation on a remote labs concept which will allow you to bring LKFT to your own companies and your own sites. I'm presenting with Chase Chi. He is a QA and automation test engineer at Linaro, and he put together the actual remote labs prototype that we're going to show. All right, so first I want to go through Linaro's LKFT and just describe what it is for those of you who don't know. So this is a project to bring Linux kernel functional testing to ARM hardware. So we test under full user space, OpenEmbedded and AOSP user spaces. This is differentiating from kernel CI, where kernel CI does boot testing on minimal images. So we're actually testing under real Linux and Android operating system user spaces. We test on a variety of hardware, and the purpose is to identify regressions against previous releases or baselines. So just imagine Greg KH pushing a release candidate. We compare that release candidate to the previous release, and that's how that's the baseline we use for regression testing. We report these results upstream, so we have reports that are curated and go to the stable mailing list, the Linux kernel stable mailing list. And we also provide detailed results via a dashboard, which I'll get into in a little bit on further slides. So the mission of LKFT was to identify kernel functional test regressions. This is the sort of the cornerstone of the whole project. But there's a purpose to it, and that's to shorten the derivative Linux kernel release intervals. So when backports are pushed to LTS, there's time it takes to verify that they're non-regression causing, and those make their way to Android common kernel, and then those need to make their way into the SoC trees, and then further on down the chain through the carriers and whatnot. The longer it takes to verify each of these stages, the more likely it is that the process breaks down, and then it's less desirable to take backports. Our purpose is to try to increase the confidence of the upstream Linux kernel engineers in the quality of their releases. So Greg KH told us probably about 2 months ago that we've already shortened his LTS RC to release process by half a day. So as far as he's concerned, that's a pretty monumental improvement already. So we hope to increase the confidence of the downstream adopters. So the phone vendors, for instance, that deploy updated kernels to their devices. We want them to know that these changes will not regress the functionality or introduce security problems to their products. So here's really the goal. We're going to go from bug fixes and security fixes. Those make their way to next, into mainline. They're merged into the long-term stable trees. Those are then merged into Android Common. Those are merged into SoC trees, make their way to the carrier where they're downloaded onto the phone. And we don't have an objective for how long that pipeline should take, because this process here is sort of a guess. We can go from here through here. We can go from here through here probably in about 48 hours to 3 days. So that's pretty good. So we're hoping that we can give downstream hardware vendors the confidence to more frequently update the Linux kernel. And the idea is that consumers will benefit from bug and security updates. So as far as the operational capacity of LKFT, what we're doing today is we're doing Project Sharp execution, which is Linux LTS and Android common kernel testing, functional testing. And that's in support of Google's Project Treble. We're also doing some Linux community upstream testing on mainline stable RC. Oh, I have that twice, but stable RC and stable and Linux next trees. Our capacity to do testing there is really limited, so that's a place where we need more help. Basically, as many bugs as we can find are available to discover there. We're also doing some SoC testing for LTS, LCR, and RPK derived trees as well. And we also have in development well, one of our goals is to be able to use LKFT for Linux kernel development testing inside of Linaro so that a Linaro kernel engineer can get results, functional test results for their patches. That's a long-term goal. It's not in the immediate horizon. And also use LKFT for LSK and LSK-RT derived trees and regression testing those. So LKFT is an interesting concept. I think most of you probably know about it. We've had questions already about collaboration, so how do members get involved? So the community can be involved by consuming the results of regression testing, and we want to improve reporting, test coverage, and the interface based on feedback. Now, as far as non-members being involved in LKFT, I know there is some interest, but right now LKFT is implemented as a privilege of Linaro membership. And any hardware that we integrate into LKFT is at our own discretion. Now, members can become involved in LKFT. While we can administer some of your devices within our own labs, we really reserve the right to choose which devices those are based upon our immediate goals. We can also support member engineers helping with device-specific triage. So if some of our landings teams, for instance, have their devices in LKFT, and that landing team will actually do the triage themselves, so they'll be involved in the process, and it's not just curation by Linaro engineers, it's curation by member engineers. But many member devices are a candidate for the Remote Labs concept, and this Remote Labs concept pushes the kernel maintenance, pushes the triage, and pushes the hardware automation integration to the member company. So that's what the LKFT Remote Labs concept is. So this is a method to extend the reach of functional testing to the Linaro members and their SoCs. And we can do it in a way that accommodates the privacy and confidentiality concerns that members have for their hardware, because I know that when you guys come out with new hardware, you want to start testing that as soon as you can, and you need to test that hardware before it's publicly available and sometimes publicly announced. LKFT Remote Labs also addresses the device complexity concerns that our engineers have within Linaro, and it respects our staff's constraints. So there are a number of decisions that hardware manufacturers make when they design a board, and some of those decisions can directly impact, very heavily directly impact, the amount of time it takes to integrate the board into LKFT and execute the board. And we have to be careful within Linaro that we respect our staff's time. And so this LKFT Remote Labs concept helps us bring LKFT to you while also allowing Linaro engineers to continue to focus on the primary mission of LKFT. So we're going to go over the proposed capabilities, deficiencies, and some compelling arguments for adoption of the Remote Labs by Linaro members. So here's an LKFT overview. It seems pretty complex. LKFT is a federation of tools that are loosely coupled, utilizing existing technologies like Git, Jenkins, Linaro Lava, and our QA dashboard called Squad. So it's a federation of tools, and they're loosely coupled, and we've coupled them together to come up with this system. So very briefly, we trigger on Git commits our Jenkins server, which is our continuous integration server. It takes those Git commits, and it uses system image definitions, and it creates file system images, puts them on our snapshot server, then dispatches through the QA server the job, tells the QA server that there's been a Git commit, we need to kick off a job. That tells the Lava system, hey, we've got a job for you, here's the test definition. The Lava server fetches the images for each of the hardware platforms, so a high-key device here, maybe a phone here, and then it tells the dispatcher, execute these tests. When the tests are completed, the execution's completed, the results go to the database. The Lava dashboard stores the results of execution in the test results. And Linaro Squad pulls from the Lava database, pulls the test results, sends out an email report, and posts the results in our results UI. So this whole pipeline, our goal that we have, well, the stated goal we have is 48 hours between the commit and the results. And we've been hitting that goal for 3 months now, I think. So we've successfully been doing this about once a week now for the Linux kernel long-term stable project. So that's a brief overview. We'll go into the details in a little bit. Well, we'll go into them right now. So I want to briefly go through each of these components. Some of these slides are a bit wordy, but I won't go through them completely. But here's how our Jenkins works. Like I said, we take our AOSP image or our OpenEmbedded image, we add our Linux kernel Git trees, and we create these system images. This is ready to be flashed to a device, and we build these images for each of the hardware platforms that we support. Job scheduling, this is actually done when Jenkins detects a change and informs the squad instance that the new system image is available for testing. So squad's the test authority, or it's the authority that schedules test jobs. So you'll see Jenkins creates the image, sends it to squad, squad sends the image to Lava. And the reason it's done that way is that squad is informed when there is a job, and squad's then the authority to dispatch it and to collect the results. Test execution, as I said before, test execution, Lava pulls the image from the server, sends the image into the devices where the testing happens, collects the data into the database, and provides the output into the Lava UI as well. Notice the Lava UI is secure, so this will be important in a few minutes. Reporting squad is not only the authority that dispatches the jobs, but squad is also the reporting mechanism that we use. So it pulls the information from the Lava database, generates the email reports, which can be customized based upon each project type, and also can store the results, or does store the results, in our website. This is also secure as well. So we can have specific hidden projects based on certain privacy concerns. So for instance, if you had a platform that you wanted to keep secure, we could have a special project just for your platform, and that could be kept secure under access control. And finally, we also have lkft.linaro.org. This is for kernel engineers, business partners, and managers. This is a website. This website's a work in progress. I'm not going to show it here because I don't want to put any pressure on Dan. But the purpose of this is to give information on the current executing builds based upon the latest commits to a certain number of trees. So this should be fully operational, I suppose, within a few months. And we collect the information from Linaro Jenkins and from the Lava database and represent it in that website. And then finally, a lot of the work that Linaro does is actually in the curation process, triaging, going through the results and trying to figure out, okay, what really happened? Was this regression caused by an infrastructure failure? Was it a kernel or test suite bug? And where do we send the results? So the default for the LTS project is we send the results to the stable mailing list. For Android Common Kernel, we send them to an internal mailing list where they're curated by the folks in LMG. For some of our landing teams, we send them to the landing teams directly. So the purpose of the curation, like I said, is to differentiate bugs, identify kernel bugs, identify test suite bugs, and send out those reports. So within Linaro's LKFT lab, we have a number of devices. What we try to do is have a bit of redundancy, so we're looking for some coverage as far as AR64. We want 2 boards that are 64-bit. We want 2 boards that are 32-bit. And we want some backups. We want QEMU, and we want x86. But we do have to be careful as far as what we bring into the lab. So this is I won't go through all of these, but this is the slide which identifies the selection criteria that we use within Linaro to determine what goes into our lab. Some devices have been extremely expensive to integrate. Some devices have been relatively easy to integrate. We learned a hard lesson with this. So in the future, these are the criteria we use to actually determine what goes into our lab. A point worth noting, not all of the devices in our lab are actually satisfy these requirements, because there are very few devices actually available that can satisfy all of these requirements. So why such strict selection criteria? Basically, I'm not going to go through all of these, but the real concern is that Every one of these problems listed introduces significant amounts of engineering effort, both in enablement and deployment, as well as ongoing effort. The more flaky the device is, the more unique the device is. If the device has problems with thermal control, all of these increase our maintenance efforts. We don't want to have to go into our lab, pull devices out of racks, reboot devices, reflash devices. So those selection criteria that we use directly influence whether we spend a lot of time doing hardware lab maintenance. So I won't, like I said, I won't go through it, but this is just here so you guys can review this later. So not only are we controlling our engineering effort and costs with the hardware, we're also looking to expand LKFT, so that's another reason why we have to be careful. We know that our LTS maintainers and our business partners and members, they want increased test coverage, they want increased tree coverage, additional hardware, and improved tools and reporting. So that's what Linaro wants to focus on. We can't just accept everyone's boards within LKFT. So we need to protect this additional future investment, and we need to be able to focus our staff on this future investment. So that's what we're talking about here with the constraining the engineering costs. So when we look at adding a new board, we have to decide whether this device is going to have a positive impact that exceeds the expense of maintaining it in-house. Like I said, some of these devices and kernel trees are easily implemented. Others are significantly more expensive. So for instance, if your hardware does not have upstream kernel support, what's going to happen is when we talked about this chain, this merge cost can be incredibly expensive. So if every merge breaks, that introduces the complexity and the cost of actually triaging that device. So we also recognize that there is value in this framework for members. And so even if we can't execute it, we know that this will be very useful to you. And we also realize that some hardware just isn't yet publicly available, but early testing is desirable. So this is a couple, well, more than a couple. This is quite a few reasons why we believe that members can benefit from the remote labs. So in particular, some that I find interesting are the easy access of desktop support for hard-to-rescue targets. So we know that there are some targets, especially the small form factor IoT-based devices, that when they're bricked, they're more difficult to rescue. They might require a JTAG interface for flashing an image on them. It's easier to maintain that device on a desktop at times than it is to maintain it in a rack, buried in a lab somewhere. And LKFT Remote Labs will actually allow you to run the full validation system fully automated against a device that's on your desktop. This will allow faster bring-up times and staging of new hardware. You don't need to wait for Linaro engineers to get your device into Lava and get your device running in LKFT. This also allows proprietary firmware. It allows you to actually test it before you make your changes. So what you can do is you can have your own LKFT remote lab, do your firmware test, verify that the latest kernel doesn't actually break with your firmware. The big one for me is this Lava integration. That can be done by members, by hardware experts within the company. Believe it or not, it's actually easier. It's actually less costly in the long run for you guys to have your own engineers do the Lava integration than for our engineers when we're looking at time to execute, access to information, particularly access to information, access to secondary peripherals and secondary tooling. And really, this pre-release is probably very beneficial to you guys as well. So I'm pretty excited that you guys can actually do functional testing on pre-release hardware with this remote labs concept. So with regard to remote labs, there is this concern about safeguarding member privacy. So as I talked about before, we know that not all your hardware that you want to test can be publicly available or have information about it available as early as you want to test it. So as I talked about, LKFT is a federation of tools, and all of these tools have privacy in mind. So with remote labs, you can maintain Git trees in private, All device availability in Lava can be maintained under access control. No one needs to know that you have devices available. Job dispatch and visibility can be under access control. Test results reporting are under access control, and bugs are under access control. So just briefly, I wanted to just chat a little bit about the member kernel, Linux kernel SoC Git trees. So what's interesting about this is when we talked about the merge from Android Common Kernel, for instance, to the SoC-based tree, you guys can easily maintain your own non-upstream SoC patch sets and any binary blobs. That's the part we haven't quite figured out yet. Like, we haven't done any testing because we don't need to do any testing with that, but I don't believe that that's too terribly complex. All right, so I want to talk about the different hosting methods for LKFT Remote Labs, but before that, I want to bring in Chase to actually kick off a demo. And this is important because the demo takes a little bit of time. So he's going to kick off the demo and describe what the demo is going to do. I'm going to go through the hosting options, and then we'll come back to the demo later. All right, Chase, do you want to come up here?
Yeah, sure. Hello. I'm Chase, and the whole remote lab will contain 3 main parts: Jenkins, and QA parts, and the Lava instance. All of the Lava instance and QA parts are on the cloud, and Jenkins is running right on this laptop. I'm just going to trigger test to skip the building part and to run testing directly, because
It's worth pointing out that this Jenkins instance is not the Linaro ci.linaro.org Jenkins instance. This Lava instance is not Linaro's Lava instance, but the QA reports instance is Linaro's QA reports.
Yeah. And this build job, normally it should be triggered automatically by a new commit. Now we're only running testing, so I triggered it manually. And yeah, that's it.
What's the demo going to show us?
This job going to run on this HKG device. So the Lava master is on the cloud, and the Lava slave is the laptop, and using HKG as a test device.
Yep. And
so I'm going to show this test job going to run a test case to turn on the LED one by one. It's a silent effects. So we should see that.
So within about 6 or 7 minutes, we should see some LEDs blinking?
Yes, if everything's working.
Okay, so if everything's working, we should see some LEDs. This is just a demonstration of a job. Obviously, Linux Kernel Functional Test isn't blinking lights, but in 6 or 7 minutes, then we should see the LEDs start to blink.
Yeah, it's not ready. And after the test job finished, we'll see the results be pulled back on the dashboard.
Okay.
And also in my email box.
Yep. So we'll look back in a few minutes, and once the lights start to blink, we'll come back to this and actually look at the results. Okay.
Yeah.
All right, so we have 3 hosting options for remote labs. One is partial hosting, one's fully hosted, and we have ultra secure. So I'll go through each of these briefly. So the partially hosted concept is based around the idea that Linaro's Lava master manages the dispatched devices within a remote lab. So this means that Linaro Lava is connected to a member Lava dispatcher via a tunnel, secure tunnel. We send images to the member Lava dispatcher, and that's sent to member hardware, and then the results make their way back to Lava master, and those results then go to our QA reports. Obviously, this will work for some membership hardware. This might not work for others. It might not work for systems that require strict network security or that have strict rules as far as what devices can access what systems outside of their labs. Then we have the fully hosted option, which is where the Git tree is available to Linaro. The Lava master is actually maintained within the member company. The dispatcher is within the member company. You have your own member URL where internal to your intranet where Lava is reporting results. The database resides within your company as well. There is a tunnel between Linaro Lava master and Linaro squad or QA reports. But the primary difference here is that the master is within your labs. And then we have the ultra secure model. This is where the member maintains the Git tree behind the firewall. If you have new hardware where you haven't yet released the Linux kernel for this, this is the model you'll need to use. So the Git tree is within your company. You have your own build server. You have your own dispatcher, your own member master, your own database. The only thing that you share with Linaro is the results information that you push to squad. And what that gets you is that gets you email reporting back into your company and gets you a private, secure dashboard of your results.
May I interrupt you?
Yeah.
Actually, before Ron asked me to kick the build, I triggered one build before that.
Okay.
To save time. The other thing is actually start running. And the next job is waiting the
Escape.
So we got 2 jobs. Oh, it's already completed. So it's quick because the time is 1 minute. Time out is 1 minute. We'll see it in the mailbox and for the report. And another job, the one I just triggered, should be.
Oh, so now we should see another job?
Yeah.
Another job starting?
This is the job I just triggered.
Okay.
Trigger. Yeah.
Okay. So this should start up again, and we should see the lights go again?
Right.
Okay.
So 2 builds.
So this is actually the model that Chase is using for the demo. Like I said, he has his own Lava, his own Jenkins. I believe he's just pulling from a publicly accessible Git tree, but that's not terribly complicated. And then he's reporting the information back to Linaro's squad instance. So like I said, he's running under the ultra secure model. This is running on the HKG18-201. He's got his ThinkPad is his Lava dispatcher. So his Lava master is in the cloud. His dispatcher is a laptop, and he's connected to devices via USB directly to his desktop. So we can have remote labs as desktop setups like this, or we can have remote labs as fully rack-mounted Lava setups within your own company. There is a little bit more complexity here because of the requirement of being able to power cycle. We do have to have a power cycle relay. We have to have a smart hub as well where we can control the hub. It's a smart hub?
It's a hub, and both the power and the USB, OTG port are controlled by the relay board. This is a mini setup. We also have the PDU and the smart USB hub here for demo Friday.
Okay, so so we'll be doing this at Demo Friday with a PDU setup as well. So this is a powered USB hub, and he's doing all the power OTG on-off reboot control with the Raspberry Pi 3 relay module. And like I said, the Lava master is running on the cloud, and QA reports is running from Linaro's QA reports. So when you look at this later, you can go ahead and hit these links, and you can see the results of the demo that he's actually running right now. So I'll skip this slide because we'll go over it once the demo is actually finished. So not only has Chase set this up, but he's also provided the preliminary information you guys need to start doing this on your own site. So you can go on GitHub and you can pick up the LKFT Remote Labs, go to the LKFT Remote Labs project. At this site, Chase shows how to set up Lava Master in a dispatcher. He shows up how to set up a Docker-based Jenkins with system image build scripts, instructions for connecting to Linaro's LKFT reporting system. The one thing we don't have is we don't have instructions on how you guys get the credentials. That's when you talk to our developer services team and they talk to us, then we can negotiate how to get the credentials to us for actually accessing the reporting system. And he also has instructions for setting up power relay module controlled by GPIO. So like I said before, if you're interested in LKFT Remote Labs, the right conduit is through Linaro Developer Services. This isn't saying that all engagements in LKFT Remote Labs are developer services, but this is the best conduit so that they can best assess whether your needs are best met by education and tutorials, or whether you are interested in having a Linaro landing team work on remote labs, or whether you're interested in having your hardware be our sort of model hardware or exemplary hardware or a reference platform, for instance. So services@linaro.org is a good starting point, and they will contact me directly as soon as they hear from any of you on your interests on the remote labs. All right, so what do we have on the demo, Chase? Is it executing now? We have...
It's still downloading the root file system. So this will take a while. But the last job is finished, and we already can see the results in dashboard. Now this one, it should be the fourth. Yeah, the results here, you can see it on the dashboard, and I should have received email reports.
Yep, so these email reports, these are templatizable. We can custom tailor these within reason. They can be sent to individuals based upon the project. So for instance, only you would get the customized email for your project with the information that's necessary, or that's useful and relevant to your project.
Yeah, that's the run for. Yeah, it matches. It's the latest report.
Let's click that.
Yeah, the first run.
So that's the test details. So this brings us back to the QA reports dashboard as well.
Yes.
Where do we look at the actual test job?
The test job is over here.
Right. Test job runs are there.
And this is the test run, and it basically gives you all the metadata, include the Lava test job. Lava test job is the one that ran 10 minutes ago.
Yep, so we can get access via that reporting dashboard to the Lava information. We can get access to the build information. So if there's a failure and you think it's build related, we can get there. So it's all tightly coupled, and it all comes through the email interface and via the dashboard.
Right.
All right, and then within a few minutes, we should probably see this start to blink.
Another round. It's exactly the same. So it's just the same.
Yep, so it's just like what you saw before with the blinking lights.
Right.
That's verifying that the demo actually ran. All right. So there is some backup material that I'm not going to go into. It just discusses kernel CI versus LKFT, and also discusses the LKFT as a service rather than a community project, and some of the barriers and concerns. These are some things that we still have to answer, but we'll answer these with you. Like I said, binary blobs, we think we can support them. We just haven't had a use case for them internally yet. How do we support custom flashing tools that are hard to integrate with Lava? That still needs to be solved. We recommend that you use flashing tools that are easy to integrate with Lava. Otherwise, you have to solve that with us, or rather solve that on your own. How do you reproduce problems that LKFT finds? That's something that I think we're actively looking at. And there is complexity in setting up the Lava master and the dispatcher. But hopefully with the education materials, access to Linaro engineers, and Chase's project demo that he set up on GitHub, it'll be a good starting point for you guys to take a look at this for yourselves. All right, well, that's all I had as far as the presentation. Do you have any questions that come to mind right away that you would like answers on? If so, you can go ahead and ask them now, or if not, I am available for the next 4 days as well to answer them. Or I believe most of you know how to get a hold of me directly, or like I said, you can go to services@linaro.org as well. All right, any questions on LKFT Remote Labs? Nothing? All right. Well, thanks for attending the presentation. Like I said, if you have any questions, either come to me directly, or if you know you're interested, just go straight to services@linaro.org. All right, thank you. Thank you, Chase, for the demo. And if you would like to look in depth at this demo, Chase will be giving the demo on Friday as well. So thank you very much.